Hello! So today we're going to talk about the independent t-test of significance. The independent t looks at the difference between two independent groups to see if there is a significant difference between those two groups. It deals with interval data. Some of the keywords that you may see with interval data are score, test, scale, number. So interval data is data in the form of numbers. The independent t-test also tests the hypothesis of difference. That means that it is looking to find a difference between groups, between different groups. The variable is also manipulated in the independent t-test. That just means that the researcher is changing something about the variable in order to see if there's a difference between those groups. The independent t-test is called the independent t-test because it deals with independent groups. And that just means that people are in different groups. And whenever you deal with an independent t, you're going to deal with two different groups. So there are two different kinds of independent t-tests. There are two-tail independent t's and one-tail independent t's. And it's really important to know the difference between a two-tail and a one-tail, because at the end of your problem, after you find your t value, when you look up your critical values on your tables, you're actually going to have two different values for a two-tail versus a one-tail. So it's really important to know the difference between the two. So a two-tail test makes no prediction about where that difference is going to be between those two groups. It's just looking to see if there is a difference between one group and another. The value of the t is also not important. So when you calculate your t, you can have either a positive or a negative number. It doesn't matter. For the one-tail t-test, however, a prediction is made. It is saying that one group is going to do better or worse, score higher, score lower than the other group. So those are some keywords that you can look for that will tell you if you've got a one-tail or a two-tail. The one-tail is looking to see if one group performs better or performs worse than another group. The one-tail t-test also, the value of that t makes a really big difference. So if you have a prediction that states that one group is going to do better than another, but when you calculate your t, you get a negative value, that means that you automatically have to accept HO. Also redo your math, make sure that there was no mistakes made, and the exact opposite is true as well. So if the prediction is made that one group will do worse than another group, if you calculate a positive t-score or t-value, then that means that you automatically have to accept HO on that. So like I said, it's just really important to understand the difference between a two-tail and a one-tail, and I'll show you the difference between each of them. I'll do an example of a one-tail and an example of a two-tail. All right, before we get started, I have gone ahead and written out a list of all the formula that we are going to need to solve this problem. Now, you need to know that there are two different ways that you can solve this problem. You can find the standard deviation and then use that to find the standard error of the mean, or you can just find the standard error of the mean with this alternate formula that we have used before. So for this video, I am not going to be finding the standard deviation and then finding the standard error of the mean. I am going to be just using this formula here to find the standard error of the mean. However, in the quick video that I have made, I have found the standard deviation and then used that to find the standard error of the mean. The only difference is that these formula here are a little less complicated than this. So using this cuts out a step, but it's a little bit more complicated. So either way will give you the same answer. It's just up to you which one you prefer to do. And if the problem asks for the standard deviation, then of course you want to go ahead and do this and find your standard deviation. But for this video set, that I'm just going to be using this here to find the standard error of the mean. Okay, so I have gone ahead and written down what formula we are going to need to solve this problem. So let's go ahead and look at our formula and see what pieces we need. Now we've got two groups here. So we've got group 1 and we've got group 2. Okay, so we're going to need an n value for each group. We are going to need a mean for each group. We're going to need the sum of squares. sum of squares, and we are going to also need the standard error of the mean. We are going to need the standard error of the difference, and we are going to need a t-value, and we're going to need degrees of freedom as well. Okay, so I have just erased our formula and moved the pieces that we need up just to give us a little bit more room. So let's go ahead and get started on that problem. A group of 20 obese adults were selected and randomly divided into two groups. In Group A, the participants were given a 20-minute per day exercise regimen and were also given information on the importance of diet and exercise. Group B received the diet and exercise information, but not the exercise regimen. Was there a significant difference between the two groups in cholesterol reduction? Okay, so let's go ahead and fill out the easy stuff first. Let's start with our N value. So for Group 1, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 for our N value. And it looks like we've got 10 for N value for our second group. Okay, let's go ahead and do the degrees of freedom. Now, degrees of freedom is N1 plus N2, that's for Group 1 and Group 2, minus 2. So for our N value for Group 1, we have 10 plus 10 for our second minus 2. That's going to give us a degrees of freedom of 18. All right, let's go ahead and figure out the mean. Okay, so we're just going to add these together. So when we add all of the numbers for column A together, that is going to give us a value of 120. Now to find the mean, we divide. So this is our EX value. So we have 120 divided by our N value of 10. That is going to give us 12. So our mean for Group 1 is 12. And then for our second group, when we add all of these together, that's going to give us 40. So we do the same thing. So 40 divided by our N value of 10, that's going to give us a mean of 4. So I have gone ahead and squared all of our raw score values here and written them down. So in order to find our sum of squares, all that we need to do is square each of our values and then add all of these up. So after we square, then we add, and if we add all of the numbers in this column, that is going to give us a value of 1496. Okay, and so for Group 1, our sum of squares is going to be 1496. And then we add all of these numbers up in the second column, and that is going to give us 188. So our sum of squares for Group 2 is 188. Next, let's work on finding our standard error of the mean. So the formula for standard error of the mean, sum of squares over n minus our mean squared over n minus 1. And we're going to square root all of that. Okay, so we have all of the numbers that we need for that, so let's just go ahead and plug in the values. And we need to do this twice because we have two different groups. So for Group 1, our sum of squares value is 1496 over our N value of 10 minus our mean of 12 squared over our N value of 10 minus 1. Okay? So when you divide 1496 by 10, you get 149.6 minus 12 squared is 144 over 10 minus 1 is 9. Okay. And then 149.6 minus 144 is 5.6 over 9. And then that is going to give us 0.622, and that repeats. And then that, after we round, will give us 0.62. And then we go ahead and find out the square root for that, and that will give us 0.79, and that's already rounded. Okay, so for Group 1, our standard error of the mean is 0.79. Okay, so we're going to go ahead and do the same thing for Group 2. Okay, so we've got our sum of squares of 188 over N value of 10 minus our mean of 4 squared over n value of 10 minus 1. Okay, so 188 divided by 10 is 18.8 minus 4 squared is 16 over 10 minus 1 is 9. Okay, so 18.8 minus 16 is 2.8 over 9. Okay, go ahead and divide that out. That will give you 0.3111, and that repeats. So we're going to go ahead and round that, 0.31, okay? Go ahead and find the square root for that, and that will give you 0.5567, and we need to round to this number here. So our final answer for that will be 0.56. Okay, so our standard error of the mean for group 2 is 0.56. Okay, so next let's go ahead and find our standard error of the difference and our t-value. So the formula for standard error of the difference is our standard error of the mean for group 1 squared plus the standard error of the mean for group 2 squared, and all of that is square root. And then our t-value is going to be the mean for group 1 minus the mean for group 2 over the standard error of the difference. Okay, so let's go ahead and plug in the values for the standard error of the difference. So our standard error of the mean for group 1 is 0.79. And we are going to square that. Then we are going to add that to the standard error of the mean for group 2, which is 0.56. And we are going to square that as well. Okay, so when we square 0.79, that is going to give us a value of 0.62. And then when we square 0.56, that will give us a value of 0.31. Okay, so now we add those together. That will give us 0.93. Find the square root for that, and that gives us 0.9643. Now remember, we have to round. So our standard error of the difference is 0.96. Okay, now we can use that and our mean to find our t-value. Okay, so our t-value, our mean for group 1 is 12 minus our mean for group 2 of 4 over the standard error of the difference of 0.96. Okay, so 12 minus 4 is 8 over 0.96. And then when we divide that out, that is going to give us 8.33. So our t-value is going to be 8.33. All right, now that we have solved everything, let's go ahead and see if we have enough with our t-value to accept or reject HO. So let's take one more look at the problem and see if we can decipher if it is a one or a two-tail. Looking over the problem, there are no keywords that indicate that one group is worse or better than the other. So since there is no prediction that is made, this is a two-tail independent t-test. Okay, so let's go ahead and plug our degrees of freedom in here. And then we can look those up on our table here. Now this is for a two-tail independent t-test. So we look down at the degrees of freedom of 18. So for the 0.05 value, we have 2.101. And then for the 0.01 value, we have 2.878. Okay, so our t-value of 8.33, is that greater than 2.101? Yes. Is that same t-value greater than 2.878? Yes. So that means that we reject HO at the 0.01 level. And if you wanted to write that in sentence form, here are our findings. There is a significant difference in cholesterol levels between the group that received the exercise regimen and the group that did not. This here is our dependent variable, and then we have our group 1, and then we have group 2. Congratulations.